Hello guys, welcome back to my YouTube channel. Today we are going to solve day 23 problem of this month on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Okay, so in this problem we have to find the cheapest flights with K stops. So we have given n cities connected by some number of flights, and you are given an array flights where flight I is going from from one source to some destination with some price. Okay, indicates that there is a flight from city to this city with cost price. Okay, and you are also given three integers: source, one is destination, and one is K. We have to return the cheapest price from the source to destination with at most K stops. Okay, so if there is no such route, then we have to return -1. Okay, so let's understand this problem with first this example 1. So here n is equal to 4. So this n is equal to 4 simply means that these are the nodes given to us, or we can say that these are the airports. Okay, this is the first airport, this is second airport, third airport, fourth airport. Okay, something like that. And these are the flights. So these are the flights. So this is the flight 1. So flight 1 is going from this source, that is 0, to this destination 1. Okay, that is, let's say this is a Delhi airport and this is Mumbai airport. Okay, so what is the total cost? It is around 100 rupees. Okay, from this source to this destination. And another flight is going from 1 to this 2 with the cost price of 100, and another flight is going from 2 to 0 with price of 100, 1 to 3 with price of 600, and 2 to 3 with price of 200. Okay, so cost prices are given to us, and we see that this is a directed graph. So from 0 to 1 we can go, but from 1 to 0 we can't go. Okay, so this is a directed graph given to us, and in this specific problem we are going to use BFS, but one more thing, we are also going to maintain the cost price. Okay, so here let's complete this input. So here source is 0, so this is our source, and our destination is 3. Okay, and how many maximum number of stops we can take here? Just 1. Okay, so here from 0 to 1 I go. What is the total price? 100. And then let's say I decided to move to this node, to this airport. Okay, so what is the total price here? So total is 100. Then I come to 1, then I reach to the total price of 200, and then from 2 can I go to this 3? No, because here K is mentioned as 1. So maximum stops I can take is 1. Okay, from this source to destination. So this is not the possibility. That is 0 to 1, 1 to 2 is not a possibility, because there are 2 stops, that is this one and then this 2. So this is not the possibility. Okay, so let's move and check some other possibilities. So 0 to 1 I go, so total price is 100, and then after 1 can I move to 2? No, we have already decided that we are not going to go this way. Then 1 to, is there any possibility? Yes, 1 to 3 we can go. So what is the price now? So initial price is 100 when I reach 0 to 1, and now total price is going to be 700. Okay, and what are the number of stops that we take? So we are taking just 1. Okay, 1 stop. So now the total our output is nothing but 100 plus 600, 700. Okay, so here one more thing, from source to destination with at most K stops. At most K stops. So at most K stops, it means that we can take a minimum stops if it's available. Let's say in this problem, if K is something bigger. So okay, let's do one thing. Let's understand with this example now. So let's say this is my source. Okay, this is my source, and now from this source to this is a new node 2, new airport. Okay, so here from 1 to 2, total price, let's say 100. Okay, so this is a one way to reach from 1 to 100, 1 to 2, that is a 100 cost price. Okay, these two are the airports. Now let's create one more path. So this is a directed graph, so let me make the arrow, and then this is one more path. There is one more node, let's say this is nothing but 3, and from this is going to be my source and this is going to be my destination. Okay, I am creating one input like this. Okay, so there is one more way like this. Okay, and from 1 to 3 total price is 50, and from 3 to 2 total price is 45. Okay, so now there is one more possibility. Okay, here if I follow this path 1 to 2, then cost price is 100, but if I follow this path 1 to 3 and 3 to 2, so now my cost price is cheaper, right? Just 95 rupees. So this is one more way. Now let's say I go to this 4, there is one more airport 4, and total price here is nothing but 20, and from 4 if I go to this 2, from 4 if I go to this 2, then my cost price is nothing but 20. Okay, and now see, if I follow this path 50, 3 to 4 20, 70, and then 4 to 2 total price is 90. So this is one more possibility. Okay, now I have got one more cheaper path 1 to 3, 3 to 4, 4 to this 2. Okay, so now let's say there is one more way. If I go to this 5, this is 5, and then I reach to this 2. Okay, so here 50, 20, 70, so let's make it a little bit less, 80, 50, 70, 90, this is 90 now, so 50, 20, 70, 80, and this is 5, 85. Okay, so this is one more cheaper path, 50, 20, 70, 80, 85. Okay, this is one more cheaper path, but here let me write it like this. Source is given to me 1, destination is given to me 2, and number of stops given to me is 2. So now tell me what is going to be my answer in this case. In this case, tell me what is going to be my answer. Okay, so here k is 2. Okay, so maximum number of stops I can take is 2. So this is one possibility, this is one possibility, right? We just we didn't take any stop here, 1 to 2. This is one possibility, we just took one stop, right? This is one possibility. And now initially when without 0 stops, with 0 stops, total price is 100. With 1 stop, total price is 50 plus 45, that is nothing but 95. And with 2 stops, now let's check with 2 stops. This is 1 stop, this is second stop, total price is 50, 20, and 20, 90. Wow, it's interesting. Now we have total price as 90. So this is a much more cheaper path with the 2 stops. Can I take this way from 1 to 3, 3 to 4, and 4 to 5, and 5 to 2? No, I can't take this path because there are total 3 stops, right? There are total 3 stops, 1 stop, second stop, third stop. So this is not a possibility. So I have to just return this 90. Okay, this is going to be my output for this specific problem, because this is the cheaper path, right? This is the cheaper price to reach from my source to destination, right? So this is what I want to explain with this example here. Okay, now let's understand how we are going to solve this problem. Okay, so before solving this problem, we have to create one adjacency map. Okay, so here let me write it like this. So this is a node 1. Okay, so from this one I can go to 3 And what is the total price if I want to go from 1 to 3? 1 is the key. Let's say 1 is the key. So to reach 3, total price I have to pay is 50. Okay, this is one case. And from 1 I can also reach 2, right? From 1 I can also reach 2, from 1 to 2. So then what is the price? Then the price is 100. So these are the possibilities. Okay, from 1. Okay, what are the possibilities from 2? So let's write the possibilities for 2. So no, okay, from 2 there are no possibilities, right? Because from 2 we are not going to any other city. All the flights are coming here at 2 position, but no one is going to any other city, right? See the adjacent map arrow. Okay, so this is clear. So from 2 there is no possibility. Now let's check for 3. So here we are creating one adjacency map. Okay, so here from 3 I can reach to city 4. I can reach to city 4 with what cost price? With what cost price? Here, see. So initially my source is going to be 1, right? Source is 1. From 1 to 3 and 3 to 4. Okay, so but now I am checking from this 3 particularly. So 3 to 4 there is one way. How much cost price? 20. 3 to 4. I am going from 3 to 4. And there is any other possibility? Yes, there is one more possibility. From 3 we can go to 2. So when my destination is 2, that is from specific from this 3. Okay, then the cost price is 45. Okay, so in this way I am creating one my adjacency map. Okay, and then for 4 we can go to 2 with price of 20. This is one this is one possibility. And then from 4 we can also go to 5, right? Here let me mark this arrow. Okay, so from 4 we can also go to 5. And what is the total price? 10, right? And now what are the possibilities from 5? So from 5 we can go to 2. Okay, and this price is 5. So here what I am writing in the adjacency maps that I am creating here. So I am writing here, this is nothing but from city, this and this. Okay, there are total 3 things I am writing. 3 things. Okay, so here first this is from city. And what is this second arrow? This is to city. And what is this third arrow that I marked? So third arrow nothing but cost. Okay, so in this way I am creating writing. Okay, so this is one key, and from this is my source. From this source to this city, price is this. From this to this city, price is 100. From this city, price is this. So in this way I am creating one adjacency map. Okay, so I am going to implement a BFS. Okay, in this specific problem. So definitely I am going to use queue. Okay, normal approach. I am going to create one queue. So initially I am also going to maintain one array. Okay, so here from source what are the number of cities total? Total number of airports 5. 1, 2, 3, 4 and 5. Okay, what is my source? My source is this. What is my destination? My destination is this. And what is my k value? K is 2 given to us. Okay, so initially in the queue my source is 1. So initially in the queue I am going to just add my source. And what is the price if I want to reach from source to my particular source only? So nothing, 0. Okay, I am at source only. So this is I have added in my source. So initially this is a base value. So here what I am going to do, I am going to, okay, initially one more thing, 1 to 1 cost price is 0. 1 to 1 if I want to go from this source to this particular source only, then the cost price is 0. And let's say from 1 to 2 I don't know the cost, so let's fill everything with infinity. I don't know the cost. Okay, so I have entered the maximum value. Okay, I have to find the cheaper value, so initially I have filled this array with the maximum values, infinite integer max value. Okay. So now first I pop this element. Okay, I pop this value 1, and this is nothing but 2 city, and what is the price? 0. Okay, so now I'm going to check for this particular key. I pop this from the queue. Okay, my queue is not empty. I'm checking for the two conditions. My queue is not empty. Yes, it is not empty because initially we have given this source and this price. My queue is not empty, and my k should be less than equal to 2. Okay, at most given as 2, so k should be less than equal to 2. So this is, so initially my steps are going to be 0 only. Okay, the steps of k value is 0 only. Okay, so now I'm going to check for this one. So from 1 I can go to this 3, and what is the price? What is the price if I go from 1 to 3? 50. Initially it was given as infinity, so now I am going to operate it with 50. Okay, this is one way. So 1 to 3, price is 50. I have popped this element. Now let me add new values here. So 3 and 50. 3 to 50. So this is one scenario. I have make note of it in my queue, that this is also one case in which I can move to this city 3. Okay, so with just price 50. Now one I can go to some other place. Yes, I can go to this 2. So 2, what is the price? 100. So initially it was infinity, so now I have updated it to 100. Okay, so this is one more scenario. 2 to 100. Okay, so now we are done with this. Okay, now k becomes our 1. Okay, we have taken one step. We have reached one airport. Okay, k becomes 1. Now let me pop this element. So now q.poll. So this comes out 3,50. Now let's check the possibilities for 3 to 50. Okay, so from 3 to 50 I can go to this airport 4 to 20. From 3 to 50 I can go to this 4 to 20. So initially when I reach at 3, the price was 50. Now I want to go to 4 from 3. So what is my total price? Initially it was 50, now becomes 70, right? 50 plus new price 70. It was initially infinity, so I have rated it to 70. So this is one possibility. From 3 I can also go to 2. Okay, so if I go from 1 to 3, price is 50. Now I decided to move from 3 to 2. So now my price becomes 45. So what is the total price? 50 plus 45, that is 90. So now this was initially 100. This was initially 100. So now I have found that there is one more cheaper price, that is nothing but 95, right? 50 plus this 45, 95. So here I have popped this 3 550, and here I am adding two more scenarios. From 3 to 50, 3 of 50 price, I can either move to this 4,70, or I can move to 2,95. Okay, these two are the cases. 4 to 70, 4 to city 4, total price is going to be 70, so I make a note of it, and then 295. So here it was previously 100, now it becomes 95. Okay, this is done. So now let me move this 3 by 50 because we have covered all the scenarios, this 4 and this 2. Now I reach this 2, 100. So from 2 I can't go anywhere, so we have to ignore this case. So let's close it. Now let's check for 4 to 10. Okay, now let's check from 4 to 10, and our k already becomes 2. Okay, so this definitely this is going to be my last step. Okay, 4,70. So 4,70 I reach here, 4,70, and then I check for the scenarios 2,20. Just this is the way. 4 to 2 if I go, then initially its price was 70, a new price is 20, now becomes 90. It was 95 here, now I have rated it to 90, right? Because from 4 we are going to 2. Okay, so here I have added one more thing. 4 to 2 I am going with the price just 90. I am maintaining the minimum key price 2,90. Okay, so this is one way. And for to 5 we are also going. So 4 to 5 when I'm going, okay, k becomes last time 1 na. K becomes last time 1 when we cover these 3 or 2. Okay, now we are in 4, so now after this step our k will become 2 after this step. So from 4 we have covered the possibility for 2. From 4 to if we go to 5, then what is the total price? 80. So 5 it was infinity, now it becomes 80. 80 this. Okay, so we have covered this step. So now my k becomes 2. Okay, so now my k becomes 2. Okay, let me delete this step 4,70. Now 2,75 this will also not work, but before that our k already becomes 2. Okay, our k becomes 2, that means that I can't take any more steps. Okay, so I have already completed at most steps. So now I am going to iterate over my array, and I will find that at this destination what is the cheapest price that I get. That is nothing but 90. Okay, so this is going to be my output. So I hope that you guys are clear with this explanation. I have spent almost 20 minutes on this example and explanation. So now let's write the code. We are going to write the same code whatever I have explained you here diagrammatically with the explanation. We are going to write the same thing. Okay, so now let's move to the code part. So let's write the code for this one. So first we are going to initialize the distance array to keep track of a minimum distance from source to each city. So for that I am going to create one array here. Okay, here let me do the full screen. So here let's create one distance array, distances. And here inside that we are just going to pass num cities. Okay, or the n number, because these are the number of cities given to us. Okay, so now after that, once this is done, we are going to fill all the elements in our distance this array with the max value of integer. Okay, as I have mentioned in while explanation, we are going to pass one infinite value, so let's pass the max value of the integer here. Okay, so this is the array, and here inside that integer dot max underscore value. So here I have filled my array with the max value of integer, and now I am going to create one adjacency list to represent the graph. Okay, so I am creating one map, and my integer is key, right? My key is of integer type, right? And after that I am passing one list of integer array. So I am going to write like this, list, and inside that list as I have told you that I am passing integers array. Okay, so these two things I am passing. Okay, so this is my adjacency list, and now this is my hash map. So new hash map. So this is how we have write the code for the hash map. Okay, so now I'm going to iterate over each flight. So for that I'm going to use my for each loop. So this see these are the flights now. So this is one array, this is a second array for these flights, this is a third array of flights. So one flight's array consists of starting, ending, and cost. Okay, so I'm going to iterate over array only. So flight, this is array, FLIGHT, over this list flights, right? And after that inside this from which city. So from city is at which index 0, right? From city is equal to flight of 0. I can write like this, flight of 0. And to city I can write it like this, flight of 1. Flight of 1. And my price. So price I can write like this, int price is equal to flight of 2. Okay, this is how I am creating my adjacency list. So inside that now let's fill the value. Okay, okay, in our adjacency list that we have created. So in this adjacency list, I am going to first check if the particular key I have calculated the values or not. Compute if absent. Okay, so I am going to check first my key from city for this particular city. If I haven't computed the values, then for this particular key I am going to create one new array list. New array list. Okay, so this is the code for creating new array list. So I have just now I have written the code for this part. Okay, if it is absent, then this is going to happen. Okay, then this thing is going to happen. I am going to create a new list. If we have already a few like in this example, if we have already this thing is available, then we have to add the next value in that case. But if it is not available, then we have to initialize, right? We have to initialize our array list. So if it is not available, then I am initializing this part. If it is available, then I have to skip this part, and after that I'm just going to add. After that I'm just going to add new int. This is the arena. In this I am passing two values. I have told you which city I am going. This is one thing that I am passing, and what is the price, total price that I have to pay to go from one city to next city. So this is how I am adding the values. Okay, so I hope that you guys are clear. Okay, I hope that you guys are clear. Okay, this part will only execute if this value is key is absent. If this key is absent, then we are creating array list and then adding this one. If it is already available, then we are skipping this part and directly adding this one. Okay, so I hope that you guys are clear. So this is done. Now we are going to write we are just going to perform BFS. Okay, so let's create, we are using queue for BFX, right? For BFS I am writing queue, and in this queue int array I am passing. Okay, and queue, and now new linked list. And now in the starting, I have told you in the starting I am going to start from my source, right? So let's add this value in my queue. Let's offer this values, offer queue.offer, and in the starting I am passing this array. In this array consists of my source, and I have told you from source to source I am going now, so distance is going to be 0 in that case, right? So here I am in queuing a source city with distance 0. Okay, so here starting distance, as I have told you, distances of source is nothing but 0. Okay, so we have updated the distance to source city. That's it. And after that, stops in the starting. Okay, in stops is equal to 0. So this is going to keep track over k value, right? How many number of stops that we are going to take. Now I am going to implement BFS traversal. Okay, so normally we use just one condition while BFS traversal for most of the problem, that is this one, queue. If our queue is not empty, till then our while loop will execute. But in this particular problem, we are going to check one more condition, and that condition I think you guys already know. That is, our number of stops should be less than equal to k. We have to stop. So here in this problem, you see I have stopped here in the end. I didn't execute further steps because my k reaches the value to this 2. Okay, so I didn't execute further. So that is why stops is less than equal to k. So here inside this, now inside my while loop, let's initialize one size, as this is giving me just queue size, queue.size. Okay, now I am going to run one loop for int I is equal to 0, I is less than size, and I plus plus. And inside this for loop, my current, I'm going to take one current, that is current element. I'm taking one element from the queue, right? Queue dot poll I told you in the while explanation. So I have picked one current element, and for this particular element I'm going to check the current city and the current distance. So int current city is nothing but current of 0, and current distance is going to be nothing but current of 1. Okay, so this is done. Now we have to get the neighbors of the current city. Okay, so for that let's propagate through our adjacency list. Okay, we have created one adjacency list now. In this, here we are passing my neighbors, right? So that is the reason I am going to write now list int. Okay, so this is my list neighbors. List neighbors is equal to adjacency list dot get to default. So this is get to default is one of the most popular method that we use for finding the number of counts in the for the different keys. So we have used it many times in our previous videos. Okay, get to default method. So for this particular current city, if it is available, then we get the values. Otherwise we are just going to pass collections dot empty list. Okay, so this is done. Now after that, again I'm going to iterate over each neighbor one by one. For int, this is array only, neighbor int neighbor over this particular neighbors. Okay, this particular neighbors. Now after that I am going to write int neighbor city. Let's get the neighbor city. NEIGHBOR, neighbor city is nothing but neighbor of 0. Again same thing, NEIGHBOR, neighbor of 0, and int what neighbor, price to neighbor. Let's write price to neighbor. Okay, then that is will be easy to read our format. Price to neighbor. So now I think it is more readable if I write variables like this. Price to neighbor is nothing but neighbor, and in 1 I am storing that value, right? Neighbor of 1. Okay, so this is clear. NEIGHBOR. I hope spellings are correct. Otherwise in the end we have to update one by one. So now after that we have to update the distance if a shorter path is found. So for that I am going to write one more if condition. If distance is neighbor city, distance of neighbor city, right, is greater than my current distance plus price to neighbor plus this price to neighbor. Okay, so if this condition is true, then in that case I am going to update my distance to this neighbor city with current distance and price to neighbor. Okay, so here I have updated this value. Now in the queue I'm going to offer queue.offer, and in this I'm just going to pass new initialize new array new int, and in the array I'm going to pass one neighbor city and my current distance plus price to neighbor. This is what I'm passing here. New values, neighbor city and current distance plus price to neighbor. Let's close this. Okay, and here one more thing. Okay, where I'm using arena, so it should be curly braces. I think I have used open braces everywhere. Let me check one more time. One more place I think I'm using. Yeah, here also it should be curly braces. Shit, so it should be curly braces na array. Okay, so here I've given correct. Okay, good. So this I have updated. Now also we are going to update one stops as well, right? Stops plus, and in the end we have to return what distances. We have to return the minimum distance to the destination city, right? Or -1 if it is unreachable. So for that, return distance dst if it is equal to integer dot max underscore value. Then in that case we have to, if this condition is true, in that case I have to return -1, otherwise I have to return nothing but distances dot dst. So now let's try to run our code and see if there are any issues. Since this is a very long code, so let's see. Let's hope we didn't do any spelling mistake or anything like that. So awesome. So all the test cases has been passed. So now let's submit it. So our solution is accepted, and I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye. And don't forget to like, share and subscribe my YouTube channel. Thank you.